All right, good morning. I'm planning on doing the Leetcode contest from Saturday 283. All right, I'm going to do this one virtually, so here we go. All right. Open these guys up. Okay. Cells in a range in an Excel sheet. Cell RC of an Excel sheet. It's represented by a row column where column denotes a column number, alphabetical letters, A, B, C, and the row is an integer. Okay. You're going to string the format row column. Okay, so begin and end, right? Original list of cells such that X is in between those rows and Y is in between these columns. The shells should be represented as strings, okie dokie, and sorted in non-decreasing order, first by columns, then by rows. First by columns, then by rows. Okay, so we want to do each column, basically. Okay, so let's do this in C++ first. Write down my game plan, and when I start 826, game plan is this. Let me see, traverse the grid one column at a time. From start, it'll be the top left, to end, which will be the bottom right. So it is inclusive, so we'll just go through those. A vector string will be our answer. Okay. Yes. And return our answer in the end, and then there's our string. So we have to parse this string row, or what is this? Column, row, column, row. Okay. Column, row. A1, B2, something like that is what it looks like. String, stream, input this guy, and then actually let's do this. S sub 012 equals empty. And then we'll parse. Actually, I don't need a string. I just take it, right? It's, see, column 1 and column 2, auto C1. Actually, let's just call it. Yeah, IJ and UV is okay, right? Top left is IJ, bottom right can be just UV, whatever, it doesn't matter, right? So I equals S sub 0, 1, 2, 3, 4, 5. I is S sub 1. Jth column is S sub 0. U is S sub 4. B is S sub 3. While J is less than or equal to B. Go through each column. Oh, go through each column. J. While C, so K can equal the first row I. Auto K equals I. While K is less than are equal to you. Go through each row, each kth row. Place back. Right, we'll want to add on to the answer the column followed by the row. So it's the jth column. How do I turn this into a string? I guess O string stream OS. And we'll input into this guy J and K. So that's the jth column, kth row. String. Okay, something like that I think works. All right, that looks right. A1, F1, looks good. Yay. Okay, 826 to 831, about 5 minutes. Not too shabby. Well, it's an okay solution too, right? Okay, let's do this in the other languages real quick. IJ equals, so it looks like this, right? S equals row column. 0, 1, 2, 3, 4. I equals S sub 1. J equals S sub 0. U equals S sub 4. B equals S sub 3. So we can stick these on a single line. Python's a little bit cooler about destructuring than C++ for those kind of things. While J is less than or equal to B, J equals 1. Turn the answer. The answer is a list of strings. K equals I, while K is less than or equal to U. Create the answer and append a formatted string of the jth column and the kth row. K plus equals 1. Not concatenate string. Okay, so the ordinal value back basically. The column. Character value of the ordinal value of J plus 1. See if that works. So transferring those to integers. See, the ordinal value of J is less than the ordinal value of B. And then I think K are integers, right? Let's just do this. How about this? Int 0. Oh, oops. It should be, this one should be a character. The other one is an integer. Oops. Okay, hold on. Since the row is an integer, the column's the character. Ordinal value is less than that. Okay. Looks good. Yay. Okay, let's stick this over here. C++, star C++, C++ solution, Python 3. All right, JavaScript. IJ equals number S sub 1, S sub 0, number S sub 0, 1, 2, 3, 4, 3, while to this board equals ordinal of a character c.char code at 0, ordinal value. Well, the ordinal value of j is less than the ordinal value, let's equal to the ordinal value of b. Return the answer. Okey-dokey. J equals ord j 1 plus that from char code string dot from char code. I think it's something like that. Okay, and then let k equals I while k is less than or equal to u. K, and then push it onto the answer and stop push. We want the jth column and the kth row. Jth column, kth row. Okay, that's good. This guy, JavaScript. Ready. Do Kotlin. Kotlin, okay. Answer equals mutable list of string. Return answer to list. IJ equals pair integer value s sub 1 sub 1 1 dot 2 int. Let's do this. Our ord equals C is character C.2 int minus 0.2 int. Ordinal value of S1 and then S sub 0, jth column, V equals pair, ordinal value of S sub 3, right? 0, 1, 2, 4. S sub 3, while ordinal value of J column is less than or equal to the ordinal value of V column. K equals I while k is less than or equal to u. So it's k, push it onto the answer. $sign. Jth column, kth row. J value j. So j is a character that we can create from an ordinal value. So j equals character dot from numeric value 1 plus the ordinal value of j. Something like that. From numeric value. Okay, so hold on. Kotlin character from ordinal value. Is it string or 2 int? It's not what I want. Working with single characters. To char. Numeric. Could have sworn there's like some from numeric value. Numeric. To char. From numeric. I want the ordinal, right? Kotlin. Ordinal to character. Something like that. Ordinal to character. Character to an integer. Hold on, what is it I want to do, right? I want to basically update j for, if j is like A, I want it to be B. What is this? Kotlin from numeric value. Number? Digit to int? What the heck? I could have sworn it was something like this. Kotlin character from numeric value. Okay, well, obviously I don't know what I'm doing here. My mouse cursor. The heck? Refresh. Oh, something's going on. Something's weird with the editor. The heck? My mouse clicks aren't registering now. Okay, what the heck? Holy cow, what a piece of junk. Can't refresh the browser. Ah, what a pain in the ass. What the heck is this? I have to click like 3 times for it to click. Well, I thought I had my little cursor there for a second. What the heck? There it is. Can't control it with my keyboard. What the heck? Keyboard is ran out of batteries. Ay, ay, ay. Welcome to programming, right? This doesn't work. Turn off my Bluetooth. Turn it on. Connect to my keyboard. Keyboard's still not working. What the hell? Ah. Does this thing work? No, what the hell? Yeah, okay, here we go. Okay, so this is working. I am able to type in Firefox. So what the heck is going on with Chrome? Right, jeepers. Is this thing working now? Okay. Yay, I can type. Yay, I can type. Again, kind of. Okay, so where was I? Struggling with Kotlin. Okay, so I want to increment J, and that's it. That's all I want to do. Just basically increment J by 1, right? So I want to, if J is A, I want J to be B, and that's as simple as it's going to get. Okay. I don't know. On the internet, there's a bunch of crappy solutions for the most part. Okay, so let me open up VS Code. I'm going to open up my Kotlin solutions. I'm pretty sure I've done this before somewhere, so. Numeric value. Hold on, let me move this over here so y'all can see what I'm doing here. This is just my Kotlin repository of solutions I've posted some time ago from numeric, get numeric value, get numeric value. Okay, that's the one I was thinking, get numeric value. Get numeric value of J. Got to char? J plus 1. Made this 1 plus that numeric value to char. Let's see what happens. Maybe? No. Oh, okay, cool. All right, so J equals that. Ordinal value. I wonder if this works. Ordinal value of J. Chuchar? Do you want to increment by 1 so it doesn't TLE? Oh, okay, cool. K1, K2, and then what the heck happened here? L1 and L2. Char. Character dot from char code. from shortcut now. Kotlin, ordinal, ASCII ordinal value to character. $97 for lowercase a. Yeah, okay, I know that, but I want to go the other direction, right? Char to ASCII. I want to go ASCII to char. To char. To char was right. What the heck? Ordinal value dot to char. What? To int. 1 plus j dot to int. To char. Okay, that was good. Okay, could not be more of a pain in the ass. Alrighty. And that's good enough. I want to move on to the next question. This has taken a total of 826 to 851, about 25 minutes. So it took me about 5 minutes each, I guess. Solutions. Traverse. Oops, traverse cells from from top left IJ to bottom right UV. One column at a time to formulate the answer. There we go. Yeah, it looks okay. All right, let's get going. Spend a lot of time on the first question. Okay, append k integers with minimal sum. Minimum. Return the sum of the k integers appended to num. So the smallest 2. What is this, 25? The 2 unique positive integers that do not appear in nums, which we append, are 2 and 3. The resulting sum of nums is 1 plus blah, 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 which is minimum. The sum of the 2 integers appended. Okay, sum of the 2 integers appended to make it minimum. 6 unique positive integers. Okay, so we want the smallest ones, basically. We'll cherry pick them, do a linear scan. All right. So the 2 numbers will be the smallest you can add, like 1, 2, 3, 4, the smallest we can add, and then 7, 8 is the smallest we can add. Okay. Num sub I, a billion, and k is 100 million. So here's the deal, right? K equals 100 million. It's gigantic. All right, so that's the bottleneck. Num's length n is 25. That's 100,000. Thus, we're looking for a near linear solution to avoid TLE, and that's the bottleneck. The key that you can bring in there they accumulated some. Ooh, I think I see. Okay, so we may need to use some of series plus sliding window to accumulate chunks at a time. Since we know a linear scan of each value will TLE, right? Result in TLE. Okay. Okie dokie. So come with the game plan and let's see where we started. Start about 8:55 a.m. Okay. So the game plan then, we want the minimum sum, so we want the smallest ones. So we want continuous chunks of a window. So we can sort A, then do a sliding window of candidates. Sort A, so that'll cost us of n log n, and then sliding window of insertion candidates. Okay, so for example, 1, A equals this guy, K equals 2. So sorted A will be 1, 4, 10, 25. Guess we can do a sorted set, right? Sorted unique set of A is this 0, 1, 2, 3. So we can start, regardless if 1 exists, we start the window, start sliding window again at the value 1, regardless if the first value A sub 0 or not. That doesn't matter. Okay, so the set is length 4. So I and J will be 1 to 4. So it'll be I inclusive to J non-inclusive then, maybe? So I to J non-inclusive. So I will actually here, I equals 2, and then J equals 4. So the sum of series from I to J non-inclusive. So then be 2 to 3. That's basically what we want. Starting at the offset of I, sum of the series offset. I guess how to offset and compute sum of series. The sum of the series is 1 through n, and that is n times n minus 1, or n plus 1 divided by 2. So 1, 2, 3. N times n plus 1 divided by 2 equals 6, right? But then if we have 2, 3, 4, then it's 9. Sum of the series is 9. How do we calculate that though? Oh, it's the sum of the series from I to j minus the sum of the series from 1 to I. Okay, yeah, that makes sense. Okay. 2x sum of series calculations. 1 to I non-inclusive. And then we'll do from I to j non-inclusive minus that. Right? Okay, so I to j non-inclusive minus that to that. Oh, it's okay. So it should be 1 to j minus 1 to I. That makes sense. Okay. Okay, so 1, 2, 3, 4. We'll calculate the sum of the series for this is 4 times 5 divided by 2 is 10, right? And then we'll subtract from 10 1 to I, non-inclusive, right? So minus 1 equals 9. Okay, so the sum of the series from 2 to 4, then take 2 absolute sum of series to formulate a relative sum of series. All right, this is my question. This is the answer. Okay, then we're going to take up to k of those at a time, k. And this one's like really hard. So we want to cherry pick k at a time. Because it's 9:03. How long have I taken? I've taken 8 minutes so far to come up with a game plan. Right, sort A, then sliding window chunks of length k. And then you have to keep into account if you want all of them or if you want less than them for each ij chunk. We have to keep into track that we only use a long for each of these calculations. The minimum sum, what you've added. Okay. I equals 1, j equals a sub 0. First value of a. First we want to sort A, right? Sort A, and then for each ij chunk, we take up to k. K values in between I and j. That's what we want. While k exists, I'll take up to k at a time. Total sum is subtracted by t. So while k exists, We'll consume up to k values between I to j non-inclusive. So make sure, first we're gonna make sure there exists a window from I to j, non-inclusive. So index. So you have two things. You have the index to keep track of, and for input array A, keep track of that, and then we also want to keep track of values between I to j. Maybe it does make sense to push one to the front of A. Do this A dot push back one. So we always have a one regardless, because that's where we always will start. I equals 0, and then start them both off at 0, then slide the window to increment it. While j is less than n, j is less than n, while j is n and a sub I equals a sub j, increment j. Okay, so now we should have some range, which will take up to k of them between I and j not inclusive. While j plus 1 is less than n. We don't want to move off to the end of it, do we? Sub j. Okay, move it forward as long as it's within a. So then we have a chunk between j. Okay, the middle in between I and j then will be what we will do this sum of the series of I plus 1 to j minus 1. Low equals a sub I plus 1. High equals a sub j minus 1. So low and high are inclusive. So if high minus low plus 1 is less than or equal to k, we can consume all of them. Otherwise, we don't want to consume them all. Oh, there's k left. Well, j is less than n, and there's k remaining to grab. Okay, so if this exceeds k, then we want it to equal k, right? high will be subtracted by the difference in which this one exceeds that. Take k away. And then k equals 0. Like, we'll consume them all. Otherwise, if it does not exceed k, it might equal k, but that's fine. K minus equals this chunk inclusive. Oh, wait, hold on, it's not. From I to j. Hold on, if I have the values, say, 2, 3, in between 1 and a sub 0 equals 1, a sub 1 equals 4, and the values in between are low equals 2, high equals 3. It's actually 2 are in between those two, so it's j minus I minus 1. Take equals j minus I minus 1. So if what we take exceeds that, however much we exceed so if we try to take too much, we want to only take up to k. So we'll reduce j by k. See, we only need to take one. If k equals 1, then high would be set to 2, right? K is 1, then high is 2, right? We just want to bump it down. Right? Instead of taking take equals 2, take equals 1, right? Then we'll take 1. Take is actually the amount of values in between those two. So high minus low plus 1. I guess it is high minus low plus 1, right? High to low inclusive. High minus equals k, and we'll take all k of them. Otherwise, k is reduced by that chunk that we take. Reduce high by k, take minus k. We want to take 2, but we only have 1, so you subtract it by 1. Okay, I think that makes sense. And then take the sum of the series of high to low and add them onto the total. Sum of the series from 1 to low, non-inclusive. Okay, so offset equals sum of the series from 1, sum of series from 1 to low, non-inclusive, low times low plus 1 by 2. Total is high to high inclusive, long to high inclusive, high plus 1 divided by 2, total minus offset. Until low, non-inclusive. Below minus 1. It's pre and cur. Cur minus pre. Total plus equals that. And then we need to update I and j. I equals j, and then j moves forward. Okay, this one looks pretty complicated as far as like debugging it and making it actually work. So I might come back to this one. This one's taking quite what is it so far? 9:18. Taken 15 over 30 minutes now, about 32 minutes, 33 minutes. Yeah, I'm gonna run out of time for this contest here pretty soon. I got 30 minutes left. Okay, so let's try to debug this, but then I don't know if I want to skip ahead or come back. All right, whatever. A equals 1, 4, 10, 25, 25. K equals 2. I and J are here at 0. 1, 2, 3, 4. Right, so n equals 5. I and j. Okay, so well, a sub I equals a sub j, move j forward. Okay. A sub I equals 1, a sub j equals 4. So low equals 2, high equals 3. Take equals high minus low plus 1, which is 2. Take is not greater than k, so k minus equals take. k will be 0. Take both of those, right? 2 and the 3. Okay, so then previous equals low minus 1, which is 1 times 2. 2 equals 1. Current equals high times high plus 1. 3 times 4 divided by 2, 6. T plus equals 6 minus 1 equals 5. That looks right. Okay. I equals J. K no longer exists. Okay, so that looks good for the first input, right? 5. Now the second input, 5, 6, K equals 6. Equals 5, 6, K equals 6. N equals, ooh, actually I do this, right? Push the 1 first. So actually we're gonna push the 1 here, then N equals 3. 0, 1, 2, 3. I and J are here. Okay, so I and J are equal. Now they're not equal. So low equals 2, high equals 4. We want to take 6. So take equals 4 minus 2 plus 1 is 3. That looks right. So K does not, or take does not exceed K. So K minus equals 3. So K is then 6. Previous sum of the series is 1 times 2 divided by 2 equals 1. Current is 4 times 5 divided by 2 equals 10. So then total equals 10 minus 1, 9. Okay, and then we're going to set I equals to J. And while I equals J, we'll move J forward. Six minus 3 equals 3. All right, there's 3 left to take. Okay, so low equals 5 plus 1 equals 6. High equals 6. Oops. 6 minus 1 equals 5. Uh-oh. That's not right. In between 5 and 6, there is no gap. J plus 1 is less than N. I want J to actually exist. We can't let J equal N here. Okay, so then let's see. If high is less than low, when they're not even equal, then we can continue. No gap, I guess. Gap. So we'll skip past that part since that's not legit. So basically, should say I equals J. If low is less than or equal to high, then we can consume it. Otherwise, we'll set I equal to J and move forward. we cannot consume it, so move I equals j. So I equals j, and then j cannot. Okay, it's an infinite loop here. The logic's not right. So if j exceeds and j equals n, break out, consume all of the last, right? T plus equals whatever is left to consume all k remaining. Okay, remaining, so a sub n minus 1. Hold on, if j is less than n, then we'll do that. Otherwise, if j equals n, that's me. So if j is equal to n, then we want to consume all the rest. We want to do 7 and 8 are the remaining. The remaining k. A sub n minus 1, the last element, plus 1. And then this one will be the last element plus 1 plus k minus 1. It's a low. Okay, so j equals n in this case, minus 6. So low is 6 plus 1 equals 7. High is 6 plus 2 equals 8. All right, k is, I took oops, hold on. Make sure my first calculation was right. 156. 2 to 4. Oh, 1 is not considered taken. Shit, I have to reconsider this part. Pushing 1 on there. Reconsider this code. I can't push that sentinel value on there because it doesn't work out. That's a corner case. Corner case to use or start low at 1. So here we start it. I guess you should probably handle that one first. From 1 to the first value. Always cherry pick 1 to a sub 0 minus 1 first. Yeah, this one's just a pain. There's lots of corner cases, and it's just a really tricky question. Kind of pain in the ass. That's a good question. Not easy to, to code here real quick. Initialize low to 1, maybe? Maybe that makes sense to keep low as 1. Yeah. UGH, let's come back. I mean, I'm pretty much like wasting my whole contest on this one question. 23 the question. Okay, 23 minutes left. Let's whatever. Let's move forward. (9:32 a.m.) Clean sheet. Q2. I see. I have a lot of room for improvement. Q2. Skipping ahead to Q3. Since Q2 will need some debugging. And we can come back, whatever. Okay, 2D integer array descriptions, parent child is left, indicates the parent or child in a binary tree of unique values. Furthermore, is left equals 1. If child sub I is the left child of parent, otherwise it's the right child of parent. Okay, fine. Construct the binary tree described by descriptions and return its root. Okay, so these are pretty much like edges. And whether it's the left or right child. The value that's not a child of anything is the root. So do a linear scan to find the root, which is not a child of anyone. Binary tree is valid for the best test cases. Okay, so to find the root, we can use deductive reasoning, right? To find the root, we can use deductive reasoning. That is like basically track children, and the root is not a child. Set equals 100. The set of kids see for how to triple and A, destructure it. So it's parent parent child I am the left child of 50. 20 is the left child of 50. 80 is the right child of 50. Unique values. Okay, yeah, it has to be unique values. Otherwise, uh-oh. But there's 2 nodes of 50. Okay, so each of them being unique is beneficial then. Has no parent. Okay, so we can use the map of parents then, and then all the scene values, right? Use a map. Here, come up with a game plan, right? Game plan. Use a set of scene parents, right? Set of parents, P. Use a map to associate parent child relationships. I think so. We can use a map, right? So 80's parent is 50. 50 has no parent. I guess we want the child, we want the relationships in reverse, like so the children of 50. Okay, so we're given as input, we are given the parents of children. We want to store children of parents, right? There's a reverse association to create tree. Use a set of scene parents P and use a map to associate parents with their children. Okay, so this one is parent child is left. We'll tie triple 0, triples 1, triples 2. Use a map to associate. How do I want to do this? The key will be the parent child and then kids. Oh, okay. So parent should be a lookup then, right? In our map of integers. Map. Okay, so given the child, this is your parent, right? So parent of the child is parent. So the root will be hold on, I'm still not coming up with a game plan very cohesively. In the end, I want to identify the root, right? In the end, I want to identify the root, the node with no parent. And I can do that using the set. Okay, so I'm kind of going backwards and forth here. On a root set, set of kids. Kids dot insert child. So the root is the only one that's not there, right? And seen. The only value seen that's not in kids will be the parent. Seen that insert child. Kids that insert child. Left or right child. For auto candidate seen. If candidate kids dot find the candidate kids dot end. Tree node star parent. Null pointer parent equals that candidate. Kids dot find the candidate equals kids dot end. Right? The parent is the only kid without that. Then we should be able to construct it. 11 minutes left. If I can even write this in 11 minutes. I'll do my best though. 11 minutes left in contest. Time to shine. Here we go. Okay, so I identified the root. Oops, not that. Root. Root is the only candidate seen that's not in kids. Okay. Given a parent, I want to be able to look up its children, right? So given a parent, I want to look up its children. So that's a map, right? Parent, child, children. I guess a child will have a value. Child of a value, and we'll have it either left or right. It's left or right. pairs equals vector pair pairs. This is a map from parent to children. Map parent to children. Okay, so map of parent to children. Right, so M sub parent dot in place back child is left. So we can construct the tree using a queue. One depth at a time. Queue. Root scene is an integer, actually. Root equals -1. Candidate is a scene value, which is an integer. Parent is the integer. So root is the value. So it'll start off at 50. While size. Okay, so do you want to look up the map to see its children? Create a new tree node with that value as the root. New tree node, so -1. Root value equals candidate. Queue of tree nodes, tree node pointers. Turn the root. To 1K depth at a time. Okay, so you can populate the queue. Current equals queue.front, queue.pop. Okay, so that's the root, and then we'll look up the root's children. Child in M sub cursive value. If child, okay, hold on. Auto children's value, and then whether if it's is left. If is left, then let's go parent. Parent's value. Parent sub left equals new tree nodes value. And then push that onto the queue. Queue.push parent sub left. Otherwise, parent sub right equals new tree node. Value queue.push parent sub right. Okay, something like that. Oh, something like that is left. Declared here. Oop, place back typo. Okay, and then Q is a tree node initialized to root. Does that look right? 5, 50, 20, 80, 15, 17, 19. I think that looks right. Okay. Let's see, to the other test case, that should be 1, 2, 0, 0, 3, 4. 1, 2, 0, 0, 3, 4. Okay, looks good. Thinking about it. Yay! Oh, just in time. All right, cool. 4 minutes left. Yay! Just in time. I was wondering if I was gonna get that one in time or not, but yeah, that's cool. Okay. A little bit tricky, but I worked through it, got it done, so that's cool. Do I need to do this? I don't think I need to do this one at a time, right? I don't need to do this 1K death at a time. So I think I can simplify this code. Oops. 4. Yep, that's cool. Thinking about it. Uh-oh. Oh, no way, it's handler exceeded. Okay, maybe I didn't need that. 1K depth at a time. Rather than going deep. Yeah, that makes sense to do it like that. Okay. Oop. Okay, so that's cool. 1K depth at a time. And then I can jam this out real quick and, okay. Let's do this in the other languages. I wonder if I want to enhance this a little bit too. So to identify the root, tracking everything that's seen and kids, but I wonder if I can identify the root by looking at the map. Every key, the map and its value. Seen in kids is okay. It's pretty straightforward to just say, hey, whatever kid is not seen is the root. I mean, it's all right. Yeah, pretty decent solution. Pretty okay solution. Okay, we've got 1 minute, so I'm just gonna probably call it a day here and say thanks for watching. I'll sell this one in the other languages and then post it on the discussion board, and then I'll come back to the Q2. Man, Q2 is a hard one. I just spent so much time on it. It's definitely tricky. It has a lot of corner cases, so you gotta be careful. Definitely, I could use some practice on this one. So, all right, I'll catch you next time.